So, okay, so we are doing 2.1, which is solving equations. So we will talk about the easy stuff today. Hopefully we finish 2.1 and 2.2. And when is your exam?
Wednesday.
Wednesday. Are you guys ready? Oh, okay. How was the homework from 1.8? Very easy?
Pretty easy.
Pretty easy? Okay. All right. Any questions about portfolio? No? Everything good? Okay, then let's continue. Now, starting from this chapter, you can use calculator, the scientific calculator. Only for chapter 1, you cannot. Yeah? All right. Now, let's start. Okay, let's see. So, 2.1, solving equations. So, let's talk about terms, which you already know. Yes. So, terms, definition. How would you define a term? So, what is a term? A term is a number or a product of a number and variable. All right. Raised to power sometimes. Variables raised to powers. So, examples of terms. -5, that is a term. 2xyz, that is also a term. All right. 3ab, that is also a term. But anyhow, you get the idea. Or even x. X is also a term. Yeah. Now, what is the coefficient? So your first definition is term. When I'm talking about coefficient, what are they? The number? Yes. So let's list down the coefficients for each of these terms. So for -5, it is -5. For 2xyz squared, it is 2, and then this is 3, and then the last one, 1. Yes. All right. So it's just a number in front of the term. If there's no number, it means it's 1. Yeah. Okay. So we talk about terms. We talk about coefficients. What about like terms? What are like terms? So the next one is like terms. Are 2 or more terms with the exact same variable parts. So the variable parts must be exactly the same. So the next vocabularies are like Okay, so give me an example of like terms. So like terms, example, what are like terms? 3xy and negative 2xy. Okay? What about 5ab? Give me another example of like terms. Yeah, negative 12ab. What about negative 2x squared y and 4x squared y? All right. Now, what about something like 6x squared y and 3xy squared? Are they like terms? No. So these are not like terms. Right? Why? Because to be like terms, the variable have to be exactly the same, including the powers. Yeah? Okay. So you guys get the idea, right? Okay. We could combine like terms, can we? Yes. Okay. So, so the next one, B, is adding, subtracting. So we could add or subtract by combining like terms. Like terms. Actually, we did this before also, but we do it again. I don't know if you remember something like this. So number one, what about if I have negative 5a minus 3 plus a plus 7? What about if I have negative 5 times x plus 2? And what about if we have negative 2 minus x plus y? So I have a negative in the front. What about if I have negative of negative x minus 2y? These are all pretty simple, and it just makes you remember, oh, if you have negative, what do you have to do? Yeah, distribute, yeah. So for number one, do we have like terms? Yeah. Which one? The a and the a? What is negative 5a plus a? Negative 4a, right? What is negative 3 plus 7? Plus 4. So negative 4a plus 4. Yeah? Good. Can we do anything else? No, not really. What else can we do here? Right? They're not lecture. Now, what about number 2? Distribute the negative. So what do I have? Negative 5x. So we use distributive property here. Negative 5 times x, negative 5x. And then negative 5 times 2. What is negative 5 times 2? Negative. Right? Okay, easy. Can we do anything else? No, they're not like terms. We're done. Yeah. Now, what about number 3? Distribute, so you have negative 2, and then plus x minus y. And number 4? X plus 2y. Yeah. All right. So are these pretty simple? Yeah, okay, good. Now, what about do a little more? If you're ready. I think you're ready, right? Okay, so let's see. What about if I have 5, 3 times 2x plus 5 minus 1. Number 6, negative 2 times 3x plus 7 minus 2x minus 5. Number 7, 8 minus 7x minus 2 plus 3x. And then number 8, we say subtract 2x minus 5 from 3x minus 2. Okay. Okay. So after this, we start the addition property of equality and then multiplication property of equality. Oh, by the way, the videos are up, the one from last week, then, on the link that I gave you. Are you guys done? Yeah, okay. So what is this? 6x plus 15 minus, the 3 is not multiplied to 1. Yeah, okay. So 6x plus 15 minus 1, so this is, yeah, 6x plus 15, finished, right? And then number 6? What do we have? Negative 6x minus 14. Then be careful here. You have to distribute this negative sign. Minus 2x plus 5. Yes. Right? Plus 5. Yeah. So this is, combine the like terms. Negative 6x minus 2x. So what is negative 6x minus 2x? Negative 8x. Negative 14 plus 5. Plus 9 or minus 9? Yeah. Negative 8x minus 9. Finish. Okay. Number 7, what do we have here? So what we will do is we rewrite this without the parentheses. So take out the parentheses. So 8, what? Minus 7x plus 2 plus 3x. So combine the x's. Negative 4x plus 8 plus 2, x. Yeah. We usually have the variables first. So I know 10 minus 4x is also correct, but we usually have the variables first, and then the number is at the end. Yeah. So if you have 10 minus 4x, we usually don't leave it in this form, even though this is correct. We usually write the variables first. So what is 10 minus 4x? Well, this is just 4x plus x. Okay. even though they're the same, but we usually write the variable first. Alright, so now this is subtract 2x minus 5 from 3x minus 2. So how am I going to do this? What did you do? Yeah, but what do you write first? 3x minus 2 minus. Do I write this correctly? No, what am I missing? Yeah, so I actually, the first one, it doesn't matter whether or not I put parentheses, but the second one, it does matter. Yeah, so this is 3x minus 2. What is this? Minus 2x plus 5. Yes, so 3x minus 2x. X plus 3. Negative 2 plus 5. Yes? Easy? Alright, good. So let's talk about equivalent equations. Let's see. So 1 through 8, no question at all, right? Okay. What do you think equivalent equations are? Yes, are two or more equations which have the same solution. Which have the same solution. Okay, correct. So to give you an example, example of equivalent equation. Okay. So the first one is 2x is equal to 16 and x is equal to 8. Those two are equivalent. Okay. The second pair is if I have x plus 7 equals 18 and x equals 11. Those are the second pair. Those two are equivalent. Okay. So those 2x equals 16 and x equals 8, those are both equations, but they're equivalent. What is the solution for number 1? For both 2x equals 16 and x equals 8. The solution is 8 for both. And what about for number 2? What is the solution for both? 11. Okay. Yeah. They have the same solution. Now, how do you make the equations equivalent? You could use the addition property and addition, subtraction, or multiplication and division property. So the addition property of equality. All right. So it just says that if A is equal to B, right, then what happens? A plus C must be equal to, what is it? Yeah, but related to B. A plus C is equal to B plus C. Okay. So you could add two same numbers to both sides, and the equation is still equivalent. Can you subtract with the same numbers also? Yes. And it's also true that A minus C is equal to B minus C. So basically, we can subtract or add both sides with the same number. So this is addition property of equality. Yeah, and this is subtraction property of equality. It just depends. So I think you know this. So why don't you write the solution? First off, meaning find the solution. Number 1. Y minus 8 is equal to negative 14. And then number 2. 12 is equal to negative 7 plus y. All right. So I want to solve for y, for number 1. What do I do? You add which one to both sides? 8, yes. So you can either write it or you don't have to write it. So you just say, oh, if this is minus, so it means I have to add to the extra. So negative 8 plus 8, this is 0, so we have y is equal to, what is negative 14 plus 8? Negative 6. So notice that what I did here is I wrote it, right? So you're adding 8 to both sides. We want to isolate the y by itself. So we have to add 8 to both sides. Why? Because negative 8 plus 8, this is equal to, what is negative 8 plus 8? 0. So we want y minus 0. So that's why y minus 0 is y. That's why we have to add 8 to both sides. Now what is the solution? What is it? Negative 6. All right. We usually write the solution in set notation. Yeah, so remember what this is? The bracket here? Do you remember what this curly bracket is for? Set, yes. So yeah, we usually write solution is negative 6. Or you can say solution is negative 6 with the curly bracket. Now, is y equals negative 6 a solution? No, it is another equation. Yeah, this y equals negative 6. This is an equation actually. Yeah, you could leave it like this and then box it and you're done, which is fine. But I just want you to know that y equals negative 6. That is not a solution. This is an equation. What is the solution? Negative 6. As long as you know that, that's fine. Yeah, so it's just a subtle difference. But if you're doing your homework and then you have y equals negative 6 and you box it, that's good enough. But you just know that this is not the solution. The solution is negative 6. Make sense? Okay. But can we just leave it like this and box it and not write this? Yes. Yeah. But just remember, that's not the solution. Now, what am I supposed to do here for number 2? Add 7 to both sides. We want to isolate y, so we add 7 to both sides. Okay. So y is equal to, what is 12 plus 7? 19. Yes. So you can box this and then you're done. But actually, what is the solution? Yes, 19, or you write it in set notation, 19. Easy? Okay. So let's use the decimal and fractions a little bit. Yeah. Okay, so number 3. All right. 1 over 5 minus 1 over z is equal to negative 1/4. So we're not going to, oh, I'm sorry, minus z. Why did I have 1 over z? Minus z. So 1 over 5 minus z is negative 1/4. And then number 4, 3.9 plus n is equal to negative 5.4. Where did I have minus z? This is supposed to be plus z. Oh, so this one is plus z, not minus z. So 1 over 5 plus z is negative 1/4. Now, we haven't learned about multiplication property, so we don't claim the fractions yet, but later on we will. Okay, so how do you solve for this? What am I supposed to do? Subtract 1 over 5 from where? From both sides, right? Okay. Good. So if I subtract 1 over 5 from both sides, I have z. Now, I am subtracting two fractions, well, a fraction from the other. So what am I supposed to do here? LCD. What is the LCD? 20. Yes. So 20. Okay. Now, what do I do to my 4? Times by 5. So this is negative 5 over 20. What do I do with my 5? Times 4. So this is minus 4 over 20. Yes. So what is negative 5 over 20 minus 4 over 20? Negative 5 minus 4. What is negative 5 minus 4? Negative 1 or 9? Yes. Yes. So negative 5 minus, so negative 5 minus 4 is negative 9. Okay. Okay. So negative 5 minus 4. So negative 1 is negative 5 minus 4. Negative 9. Yes. So that's why this is negative 9. Yes? No? Yes. Okay. Good. Now, how do I solve for number 4 here? Oh, okay, yeah, but we're not doing it yet because we didn't learn the multiplication. Yeah, but we usually multiply it like that. Here, we also multiply by 20 both sides, right? Yeah, so let's wait multiplying by 20. So we'll just keep it the way it is. So we will what? Can you multiply by 10? Absolutely. Yeah, but I just will do it now. But later on, in 5 minutes, I will. Yes. Okay, so m, this is, what is negative 5.4 minus 3.9? Negative or positive? Negative, and you add the absolute value, 5.4 plus 3.9, which is 9.3. Yes. All right. Oh, I forgot to write. But basically, if you do like this and then just box it, you're good. But that is not the solution, right? The solution is negative 9 over 20. Yeah? Which is fine. You can just box it. Solution is negative 9.3. Okay? The bracket like this? The set bracket? You can use this to write down the solution. Yeah. No, you can just, as I said, you can just have these and box it. But just so you know, those are not the solution. The solution is this number only, negative 9 over 20, or you can write this number with the with the set bracket. Yeah. Okay. This is an equation. Z is equal to negative 9 over 20. This is an equation. Well, the solution is negative 9 over 20. Yeah. Okay. All right. So anyway, multiplication property of equality now. So is it E or E? Okay. So multiplication and division property of equality. What do you think I'm going to write here? I think you already know. Right? All right. So what does the property say? So if A is equal to B, then A times B is equal to? So look at this. I multiply with the exact same number, and these two are still equivalent. What else? A divided by C is equal to B divided by easy? Okay. All right. So this is multiplication property of equality. This is division property of equality. Which is very simple. So for example, solve. Oh, this is another easy thing. Number 1, 5x is equal to negative 3. Number 2, negative 3.4x is equal to negative 20.4. Number 3, A over 4 is equal to 13. Number 4, 3 over 4x is equal to 27. Number 5, 2 over 7 is equal to x over 3. All right. So again, I want to get x. This is A. This is not 9. This is A. A over 4 is 13. So for number 1, what am I going to do? Divide both sides by 5. Yes. So if I want to write it, I'm going to write it to both sides. Divide by 5. I don't want to do this. Why not? What's wrong with this? Is 5x equals to 80? Negative 80, sorry. Is this equal to 5x equals to negative 80 divided by 5? No. That's why I don't want you to write it only to one side. If we write it, we have to write it to both sides. Yes. So yeah, when you add, you have to do it to both sides. When you divide, you have to do it to both sides. If you decide to write it, if not, then don't write it. Yeah. Good. So what is x equals to? Negative positive? Negative 16. Yes. Yeah. The solution is negative 16. I didn't write it. So you can write it. Negative 16 here. That's the solution. Okay, what am I going to do in number 2? Divide both sides by negative 3.4. Oh. All right. So this one you could use calculator, or you could use, well, let's do it on Scratch. So this is my Scratch. I have to erase this, right? I have to erase this or do it on scratch paper. So 20.4 divided by 3.4. What am I supposed to do first here? Move which decimal? The 3.4 first? Okay, so we have to move 3.4. That's why I need to move 20.4. So this is what? 204 divided by 34. What is 204 divided by 34? Oh, 6 exactly? Oh, okay. Is it? Oh yeah, that's right. Yes. 6 times 34 is 204. Alright, so this is 0. Okay, so x is 6. Okay. And my solution is 6. Okay. Now, do I want to leave my scratch here? Not really. Let me erase it. I'm not supposed to have my scratch on my paper, right? It has to be done on a different piece of paper. Okay. Or you have to erase it. Yeah. Okay, now number 3, what do you do here? Yes. So this is a over 4, and you have to multiply both sides by 4. Yeah, it's a. Did you think it was 9? Yeah. No, it was a. Yes. So the 4 cancel. What is 13 times 4? 52. Yes. Good. So the solution is 52. Okay. Only one solution. It's 52. Okay. So good. Now, how about number 4? What would you do? Multiply by the reciprocal, which is 4/3, both sides. Okay. So the 3 and the 3 cancel, the 4 and the 4 cancel. We are left with x. So x is, oh, the 27 and 3 cancels also. So 9 times 4, 36. Which one? Yes. You can. Yeah. So Salman has a question. Can I just multiply the number 4 by 4 to clear the fraction? So you have 3x, right? 3x is equal to 27 times 4, which is 108, and then divide by 3. Yeah, you can. But here it's actually easier to see if you multiply by the reciprocal. It's faster. But yeah, you can. Yes. You're right. Now, what about number 5? You could cross multiply, right? Or what do you do here? Because I just need to solve for x, so how do I isolate my x? Multiply by 3, yes. That's it. Yeah. Or you could cross multiply, but then you have to divide by 7. Yes. So here, 6 over 7 is equal to x. All right. So you're done, or you could write 6 over 7. Okay. So everything is easy so far? Yeah. Okay. So we're going to use the 2 properties together. Yeah. So this will be longer one. All right. I'm done with 2.1. So this is 2.1. Yeah. Okay. So let me save this. I'm glad you think this is easy, because the next section maybe is a little bit more difficult. So let me close this first. It will be due on Wednesday. The homework will be due on Wednesday. So we are finished with solving equations in 2.1, which was easy, right? So we will do 2.2 right now, because to combine the principles together. All right. So using the principles together, this is 2.2. Yeah. Okay. So let me close this first, and let me share the desktop. share. All right. Okay, so now 2.2 is using the principles all together. All right. Are we okay so far? Okay. So, well, this is a little bit more because we have fractions. So let's do without fractions or decimal first. So first, solve. Apply solve by applying both principles. Okay. So what do you do first? What we need to do is clear fractions or decimals. If necessary. Remove parentheses by applying distributive property. So this is if necessary. Also, if we don't have parentheses, then we don't need to do it. Okay. 3. Combine my terms. 4. Use addition property to isolate the variable on one side. One side of equation. So I'm just going to put one side. 5. Then the last one we use is use multiplication property. So we usually use addition first and then multiplication. All right. Okay. So, for example, 5y minus 2 is 28 minus 1. So, do I have parentheses or fractions or decimals? No, I just need to isolate the y's on one side. So which side do you want? Yeah, but which side do you want? Left side or right side? It doesn't matter. Yeah. So you want the y on the left? Okay, so I'm going to move this 2, this negative 2. How? You add 2. Okay, so let's do it one by one. You can do them together. So we have 5y is equal to 30 minus y. Or you can add y first. Doesn't matter. So now you see, oh, I want my y to be on the left. We will add the y. So we use the addition properties here 2 times. So 6y is 30. What is y? 5. And then you can write the solution is 5 if you want. Is it easy? Okay, can you try a few? Okay, so number 2. Alright, so 7 minus 2r plus 8 is 32. Okay. And then number 3. Let me see if I have space here. 13 minus parentheses 2c plus 2 is equal to 2 times c plus 2 plus 3c. What's the answer for 2? Negative what? 8.5, is it? Oh, positive or negative? Negative 16.5? Okay. Maybe, I don't know. I didn't do it yet. But you can check your answer, right? So, how do you do number 2? Yes, so you're at 7 minus 2r minus 8 is equal to 32. So I'm going to combine like terms first on each side. 7 minus 8 is what? Negative 1. So negative 2r minus 1 is 32. Okay, I have to move this, I guess. Okay, so now how do I proceed here? I need to isolate the 2r, the r, so we add 1 to both sides. Yes. So negative 2r is equal to 33. All right, and then divide both sides by negative 2. So I could write the division by negative 2, or I could just do it on my head. Okay. So negative 2 and negative 2 cancel. What is r equals to? So we could leave it as negative 33 over 2, or we can use decimal. R is equal to negative 16.5. Or you could also say negative 16 and a half. So any of these answers will do. If you said Math Excel, sometimes tell us, oh, answer an improper fraction or answer a mixed number. Did it tell you? Yeah. Yeah, then you have to read what they want. Yeah. Because you know Math Excel is, I call it stupid. They cannot think, right? So if they tell you to answer a mixed number, then they expect you a mixed number. So they don't know that their equivalent. Yeah. All right, good. So you can write any of these solutions right here. Are we okay so far? Okay, so I'm going to do the third one on the next page because I don't have space. Are we ready? Okay. All right, so edit page. Okay. Okay, now tell me what we're going to do first. Distribute? Yes. So 13 minus 2c minus 2 is equal to 2c plus 4 plus 3c. All right. Combine like terms. Negative 2c plus 11 or 11 minus 2c. Yeah, that's right. Equals 2c plus 3c. 5c plus 4. Okay, good. Now, we have to make decision. Where do you want your C? Left or right? It doesn't matter. Maybe on the left? Okay, on the left is fine. On the right is fine too. So just say I want it on the left. What am I supposed to do? Subtract 11. Can you put it on the right? Yes. It's up to you. But if I want it on the left, I'm going to subtract 11. So negative 2c is equal to 5c. What is this? Plus 4 minus 11. Negative 7. All right. Now, I still have c on the right, and I need this to be on the left. So what do we do here? Subtract 5c. All right. So negative 2c minus 5c, what is that? Negative 7c is equal to negative 7, yes. So what is c equals to? 1, yes. It doesn't matter whether we put the c on the left or on the right. The answer is still going to be, yeah, the answer is still going to be 1, yes? Okay, so now let's do more fun with fractions and decimals, right? Okay, so we could clear fractions. So here is equations containing fractions or decimals. Or decimals. How do you clear fraction? To clear fraction, what do you do? What do we do? Yes. To clear fractions, we multiply both sides by, well, both sides mean each term. Okay, so both sides are each term by the LCD. How do we clear decimals? To clear decimals, multiply both sides by power which is 10 or 100 or 1000, depending on the number of decimals. Okay, so solve. All right. Move on. 2/3 plus 40 is equal to 60 minus 2/15. Okay, so what do we do here? So we have 3 and 15. What's the LCD? 15. Which one do I multiply by 15? Which one do I multiply by 15? 2/3? Okay. What about the 4t? Yes. So you have to multiply each term, right? Because otherwise it's going to get jealous. Yes. So you have to multiply each term by the LCD. So you can't just pick and choose, oh, I'm going to multiply this with 15, not the other ones. No, we are going to change the value in that case. So better we multiply each one by 15. So here, what do you want? What do we have here? 3 and 15. This is 5. Okay, and then this is 15 and 15. All right. So now, what do we have here? So now I shouldn't have fractions anymore because I cleared the fraction. So we have 10 plus 60t is equal to what here? 90t minus 2. So 2 times 5 is 10, 15 times 4 is 60, 15 times 6 is 90. All right, then do I still have fractions? No, I don't. So I could actually proceed to do what I'm supposed to do. So let's put the t on the left or on the right, it doesn't matter. Yeah, so let's put it on the left. So how do I put the t on the left? Subtract 10 if I want the t on the left. So we have 60t is equal to 90t. What is minus 2 minus 10? Okay. All right. Then, yeah, subtract 90t, both sides. So 60t minus 90t, that is negative 30t, is equal to negative 12. Okay. Now what am I supposed to do? Divide by negative 30. All right. Okay. So t is equal to positive, right? Then how do you reduce this? By 6. Okay. So 12 divided by 6, 2, 30 divided by 6, 5. So that's it. Your t is 2 over 5. Most likely you'll have to use fractions here. Why? Because we start with fractions. So our answers end in fractions. Yeah. If you start with decimal, then the answer will be in decimal. Are we okay? All right. What about if you do this, number 2? So 1/3 x plus 2 over 5 is equal to 4 over 15x. 4 over 15 plus 3 over 5x minus 2 over 3. So 1/3 x plus 2 over 5 is 4 over 15 plus 3 over 5x minus 2/3. So what do we do now? We multiply by the LCD, which is 15? Yeah. Okay, so 15. So we write 15 as numerator, right? So 15 is the numerator. All right. Good. Okay, then what? The 15 and 3 cancel, so we have 5. The 15 and 5 cancel, so we have 3. Right. So let's write down. So we have 5x plus, we have 3 times 2, which is 6. And then the 15 and the 15 cancel. So we are left with 4. Okay. The 15 and 5 cancel. We have 3. So we have 3 times 3x plus 9x. And then 15 divided by 3 is 5. So we have 2 times 5, which is minus 10. All right. Good. So what is this here? 14x. Oh, what am I doing? They're not one side, right? So 5x plus 6. And combine like terms here. 9x minus 6, yes. Yes, no, maybe so? Okay, then what? Where is your x? So you have to make decision. Where do you want your x? Left or right is okay too. It's just you have to do something different. If it's on the left, then you have 5x is equal to 9x minus 12. Okay, and then subtract 9x. All right, so what is 5x minus 9x? What is 5x minus? Yes, negative 4x is equal to negative 12. Yes, and then divide by negative 4 both sides. X is equal to 3. All right. Then we are done. So doable? Doable? Easy? Okay. So I will continue tomorrow. I'm not done. I want to give a few more examples, and then we didn't do the decimals yet, right? And we will also talk about contradictions and also identities. And we will finish 2.3 tomorrow. Yeah. Oh, by the way, did you download the sample test? Yeah. Okay. Did you start working on it? Yeah. You should, because we have a test on Wednesday, right? Yeah. Okay. Your first test would be easy. And on the first test, you cannot use calculator. Yeah, chapter 1, you can't use calculator. So after that, you can. 2.1, 2.2 will be due on Wednesday. Yeah, Wednesday night. All right, so let me save this. And then I call the attendance. Did I call attendance? Oh, I did. Yeah, so math 115. Okay, so who came late? What's your name? Oh yeah, that's right. Okay. Okay guys, we'll see you tomorrow. Yeah. Okay, call. Okay, we're not done with 2.2. There will be more examples of equations containing fractions and decimals. Okay.